behaviors and interlocks. The difference between a behavior and an interlock, a behavior automatically happens. So we manipulate it, so if this is a condition to automatically do that. With the behavior, you won't get any prompt. The interlocks are set to give you a prompt. And even though that condition might clear, that'll stay up here until you acknowledge it. Let me come back here. No, explain that better in university. So system users. I don't know how this university is set up. Some universities, they work with outside contractors. They'll train somebody on a tool. Maybe they're just doing research on one recipe. I don't know if you're planning to do that or.
No,
Okay. The users that are on here, you have two. You have KGLC and admin. I would keep both of these. Yeah. I'm doing something here. I'm changing it. I'm saving it also. So if you wanted to have individual settings, so everybody or maybe certain specific people only have access, you can put their own username, you can set them up with a little bit of an account here, and the buttons will determine what they have, what they're allowed to do, so you have some control over here. You know, whether you want them to be able to edit recipes or see other peers to the same level, so if they're at a technical level or technician level, they can see other technician level recipes. So this just sets up what you allow them to do. On here, there's something called button configuration. The button configuration sets what buttons you have all around. So you can change it. You can have different button configurations. Maybe some people, you want to have a button configuration where the recipe editor isn't even on here, or the maintenance and the UI configuration is disappeared. Admin and KGLC is set up as super users, so you have access to everything. But you can control what the individual operators have access to. This is covered pretty well in a manual. If you want to experiment with that, you can come in and create a fictitious user and change what the permissions are, and then go back and see, oh, okay, they can't see this or they can't do that. That's really the best way to learn if you want to do that.
We are just going to be few of us using it. I don't think we need a
yeah, the option there if you choose to. And that's with both of these systems. Everything I'm covering right here is redundant on both of those.
It's more complex than everyone thinks, like can work with that without any coordination.
Yeah, well, the software set up for some universities, they might have 50 users.
Yeah.
And that's, you know, that's 500 of these. You can get a lot of trouble with that. So they set it up, okay, they limit how much different users can, what they have access to and what they can control. Email setup, the last I know this wasn't set up to automatically flip, so I think this is just missing in the software for future reviews. Heater setup, you may come into here. This gives you a whole lot more information than what operation and heater. So you only have a little bit here. This maintenance, heater setup, you have both your thermocouples reading. You have a ramp option if you want to control it for your system heaters, along with your substrate heater. The enabled and enable are both redundant.
this one is click button. This one is indicated.
Sure.
These are all input.
Yeah, now you can input the temperature on
These are
operation. You can't input a ramp if you're doing it manually. The recipe does everything the way it's set up right now. If you want to change something and do a manual operation, you can do it from here if you want to do a ramp rate. You can't put a ramp rate in from operation. You can,
Here you can.
yes, if you're doing it manually. There's a position in the recipe where you can put a ramp rate, so the recipe automatically populates it.
Okay.
Some people maybe don't want to give them all this information. Also, if for some reason you're only using one thermocouple and you don't have two, maybe one went bad and you only have one and you order some more thermocouples, you can disable the second overtime. So you can disable,
Where is the second one?
here's the,
Oh, second one.
yeah. So on this channel right here, the ampule heater, there's nothing plugged into TC1,
Yeah.
there's nothing plugged into TC2.
Yeah. Why the arrow? The why the arrow is one time.
Yeah. So there's an error. Whenever we go into doing a little bit of training with the ampule heater, we'll actually create errors by plugging the thermocouple in and out. So if we unplug one of these thermocouples, okay, so I'll give you an example right now. So this source one valve here, if I were to say a thermocouple broke, I'm going to just disconnect it for right now. You might want to look at the screen while I disconnect it. Okay. So now I'll reconnect it. Okay, I replaced the failed thermocouple. So I can come in here, hit reset, and it'll reset it. Yep. If I want to start it again. It's already up to temperature, so I'll just punch in the same value. I don't have to worry about a ramp, it lose any temperature. So this is your overtip set point. Sometimes this matters. So for in the case of zirconium, you heat it up to 75 degrees C. You don't want to overshoot because you don't want to thermally decompose it. So in that case, you might want to put the over temperature at 80, just so you don't have an overshoot. On here, there's our PID zones that you can call up. Most of them have a name that corresponds to that heater. It's already set. These are the PID values, and this is what's possible.
So we don't need to change it.
You won't have to change them. They're already set to tune. If we get into real weird temperatures, we might change that a little bit. You have some of the same inputs as you did on the other screen. There's actually something here on this screen as a PID table. You can bring the PID table up. And from here, you can input your PID values. In this case, you save and export the controller. These values are held in the controller. They're not held in the computer. Your interlocks, those values are held in the controller. Recipes are held in this computer. So whenever you hit run recipe, once that recipe is pushed down in the controller, then the computer is just used for information and feedback. You can unplug the computer and this will still run its process. Also in this PID table, you could limit the output. So you could, what the max output of the heater is. So you can limit to 20, this is in percent. You can limit to 25% output. On your ampule heaters, if you choose to, we have ampule heating recipes. You'll have two different PID values. You have a heater ramp with no integral, and you'll have steady state, which has an integral. So whenever we're running an ampule heater recipe, not the normal heating recipe, on ampule heating recipes, so if we were heating up zirconium 75 degrees C, the recipe will say set point 75 degrees, input heater ramp, no I value. So that'll be almost linear whenever it's coming up if you look at it on a graph. Whenever the recipe will say whenever it hits 70 degrees, shut off the heater, put in the different PID values in steady state, which incorporates I, and then it'll go from 70 to 75 with the incorporation of the I. What this does, it prevents integral wind-up, so you don't have that overshoot. The last time, actually I just did this like 2 or 3 weeks ago, and running the recipe on zirconium with these PID values, the overshoot from 75 degrees C was 0.65 degrees, and then the undershoot after it was like 0.15 degrees, but still within 1 degree. You're not going to thoroughly decompose that material. That's how you want that to run. So in regards to the ampule heating, that's the reason why you have 2 different sets of PID values. And then we just have this as a ceiling, acting as a buffer. You can input any PID values you want, but this is set up for normal operation what most people use. More so you're aware that it's there. If you get into running something other than half-moon or zirconium, then maybe we might change the PID values. Or we could go ahead and tell you to wrap the heater on an empty ampule, water ampule, maybe not that exact precursor, and then we'll run the temperature up to whatever we think should happen, and then we can run a tuning program to go ahead and tune to those PID values, which is a different set of software. Then we can have the new PID values and put it into the table, then you'll have it. You won't be using that in the near term. Maybe future use, but this will work just fine for what you have. Just so you're aware of where it's at. And these are redundant as